Okay, I'm sharing my screen. Is my screen visible? Hello?
Yes,
Okay, okay.
Yes, sir. Visual.
Can you see my screen now?
yes,
Okay. So we'll start from
Yes, sir.
the topic which we left in the last class. So we will start reheating in the gas turbine. So what we discussed in the last class that the efficiency of this gas turbine can be improved by three processes. First one is the regeneration in gas turbine. Second is reheating, and third is intercooling. So regeneration we have already discussed, and we have done one numerical also on that, which was asked in the exam. Now we'll discuss the second topic, that is how we can improve the efficiency. That is by reheating in gas turbine. So basically, what do you mean by reheating? Hello,
taking
heating again,
steam and
what?
heating the steam again.
No, no. Here we are talking about gas turbine now. So we'll steam. We will talk about an steam cycle, that is Rankine cycle. Here we are talking about gas. So the working fluid will be a gas. So what we will do, you have said right that reheating is the steam or working fluid, you can say it will be a better name. So in this process, what we basically do is reheat the working fluid, which is in case of gas turbine is a gas coming out of the turbine in more than one stages. Stage I will discuss this. So in this reheating, what we do, suppose this is a cycle, ts diagram so this is a ts diagram. So what we are doing, we are the steam which is coming out, uh, suppose this is the temperature T3, maximum temperature coming out, the steam coming expanding after the turbine, it is again heated to same temperature, or it can be more. So T5, it is T4, and it is T6. So we are reheating, this is reheating again. So by virtue of this, what will happen, the turbine work will increase. How it will increase? Because previous turbine work was Cp T3 minus T4. Previously what we were doing, we were expanding it here and then going directly here. Okay, now what is happening, we are again reheating at some intermediate state to temperature T5, which can be equal to T3 or it can be greater than T3. So because of this extra work, we are getting turbine work. So what will happen, turbine work will increase, that is T3 minus T4 plus Cp into T5 minus T6. So this extra turbine work we are getting due to reheating. Okay, so the cycle I'll draw it little more clear for you. Is it fine now? Previously it was looking like a hodgepodge. 1 2 3 4 5 6. Okay, and this only, that is temperature entropy curve. Is it fine till now? So what will be the effects of this reheating on the all the parameters which we have discussed. Effect of reheating. So as to what will be its effect on turbine work? It will increase.
Increase.
Okay. So compressor work.
Remain same.
Yeah. No effect. So, third, network output.
Increases.
Yeah. Because turbine work increases. That's why. And the fourth one is heat addition.
Increases.
Yeah. Why it is increasing? Because previously heat we were supplying was H3 minus H4. Now we are supplying QH dash is uh, no. Previously we were supplying H3 minus H2, and now we are supplying. In addition to this, we are supplying H5 minus H4. Therefore, QS also increases. This increases. Okay. Now, what will be the effect on the heat rejected QR?
Increases.
Heat rejected. Yeah, it also increases because previously it was H4 minus H1, and now it is QR dash. It is H H6 minus H1. So it increases. Now, um, mean temperature of heat addition.
Increases.
Yeah, it also increases because we are again reheating. Now, mean temperature of heat rejection.
Increases.
Yeah, and efficiency. What will be the effect on the efficiency? Efficiency, what we know, network output upon heat addition. So, what will happen?
Both are increasing. W net and QS. Can't say.
May or may not.
Yeah, we can't say anything about it. We have to calculate it both. Then only we can comment on it. Otherwise, we cannot say anything. Now, what will be the condition? Now we'll derive a condition for the maximum work uh, condition for maximum work output with perfect reheating. Okay. So what?
Sir, I have one doubt.
Yeah,
Sir, how heat rejection increase?
heat rejection. See,
Yes,
previously heat was rejected. Can you see this diagram? Previously, what was happening? Heat was if we
yes,
draw, this was the previous cycle. Dash dash dash. This one.
yes,
Can you see? So previously we were taking this point as point
yes,
4.
sir.
Okay. So heat rejection temp. What is the mean temperature of heat rejection? It is T4 plus T1 by 2. So now because of reheating, TMR dash, what will be the T6 plus T1 divided by 2. So since T6 is increasing, temperature T6 is higher than T4. Therefore, the mean temperature of heat rejection is also increasing. Have you got that? Hello.
Yes, yes,
Okay. So, should we derive or should I
yes,
tell
sir.
you? Hello. Should we derive the condition or should I tell you directly the conditions? What do you want? Hello.
Derivation is small, then derivation is fruitful.
So you want derivation also?
If it is small,
It is so okay. I'll do it in a smallest possible way. Rest you can do the in between calculation. Okay.
okay, sir.
So for perfect reheating condition. For perfect reheating, the diagram looks like that, TS diagram. One, two, three, 4, 5, 6. So this point is same, this point is also same. So what we will get here for perfect reheating, T3, T5, T4 and T6 should be same for perfect reheating case. Okay, so for what will be the we will here find out the condition for the perfect reheating. Okay, so for maximum work output, when we will get the maximum work output for perfect reheating condition. So what will be the turbine work here? Network output is basically we know what it is. Network output, turbine work minus compressor work. So only turbine work is changing. So what is turbine work? It is turbine work 1 plus turbine work 2. Here two turbines are there na. The first one, it is the second one. So WT1, what will be the WT1?
H3 minus H4.
Yeah, and WT2?
H5 minus H6.
Yeah, okay. So the turbine work will be H3 minus H4 plus H5 minus H6. Okay, so we can also write turbine work is equals to Cp. Now we'll take out T3 common from there, and what we will we will get. Wait, I'll write in. Otherwise you will get confused. Cp T3 minus T4 plus Cp into T5 minus T6. Okay, so T3 we will take out common, 1 minus T4 upon T3 plus Cp into here we will take out T5 common, so 1 minus T6 upon T5. Okay, this we will take equation number 1. Now we know that for isentropic process, we know that for isentropic process, here the in turbine the expansion of turbine is a isentropic process. Therefore for turbine 1, that is for 3 to 4 and 5 to 6 we will write. Okay, so here we can write T3 minus T4 is equals to P4 upon P3. Wait, I'll write the pressure also, otherwise you will get confused. Here P2 is equals to P2 is equals to P3 is equals to P higher we can write, and for here we can write P1 equal to P6 equals to P lower, and for here we can write P4 is equal to P5 is equal to P intermediate. Okay, because it is a intermediate pressure between lower and higher pressure. So what we can write, P4 upon P3 for isentropic process, 3-4 for the first turbine. We can write this upon gamma minus 1 upon gamma. Similarly for process 5 we can write T6 upon T5 is equals to T6 upon T5 upon gamma minus 1 upon gamma. Is it okay? Hello?
Yes, sir.
So this we will take 2. Now we will put 2 in 1. So what we will get here, work done by turbine is equal to Cp T3 1 minus P4 upon P3 gamma minus 1 upon gamma plus Cp T5 1 minus P6 upon P5 to the power gamma minus 1 upon gamma. Okay, now what we know that P2 is equal to P3 is equals to P higher. We have taken higher pressure, and P1 is equals to P6 is equals to P lower pressure, and P4 is equals to P5 is equals to P intermediate pressure. Is it okay? Now we will substitute this value in the above equation. Here we will substitute this. So what we will get, the turbine work is equals to Cp T3 1 minus P4 is the higher, P4 is what? Intermediate pressure. Okay. So Pi upon P3 is higher pressure into gamma minus 1 upon gamma plus Cp into T5 1 minus P6 is the lower pressure. So PL upon Pi upon gamma minus 1 upon gamma. Is it clear till now?
Yes, sir.
Yes, sir.
Okay. So here for we can we know that for perfect reheating, what we have assumed that for perfect heating T3 should be is equals to T5. Is it? Hello.
Yes, sir.
So for perfect reheating, it is higher temperature both are equal. That is
Or this perfect heating is equivalent to perfect regeneration.
no. These are totally different. In regeneration, what we are using, turbine exhaust gas we are heating to increase the temperature of the already compressed air. Okay, here we are not doing that. Here we are increasing the turbine work. Okay, there we are at in regeneration. What we are doing that we are basically reducing the heat addition. Okay, that is
Okay.
S3 minus S2. So main aim there is to reduce the heat addition and then increase the efficiency of the cycle. So here what we are doing, here we are increasing efficiency of the that is network output by increasing
Workout.
the by increasing the turbine work. Okay,
Okay.
so for this is the condition for perfect reheating. Okay. So if we will put this in the above equation, what we will get? Since Cp Cpt is this and this will become equal, so we can take that common because Cp is common for the gas and T3 and equal to T5, so we can take this as common. So Cp T3, okay. So 1 minus P intermediate upon P higher to the power gamma minus 1 upon gamma plus 1 minus P lower upon P intermediate upon gamma minus 1 upon gamma. Okay, so what we will get? 2, 1 plus 1, 2 minus P intermediate upon P higher upon gamma minus 1 upon gamma minus P lower upon P intermediate to the power gamma minus 1 upon gamma. So for what we want, for maximum for maximum work output, for maximum work output, what we want?
Differentiate with respect to
Yeah,
PI.
yeah. So what we will do, we will differentiate above equation with respect to Pi and equate it to 0. Okay, so after differentiating, I am writing directly the result. You can do that at home and you will find the same result. Okay, so what we will get after that, rearrangement and all. Wait, I'll write the first that differential, uh, gamma minus 1 upon gamma P intermediate gamma minus 1 upon gamma minus 1 upon P higher gamma minus 1 upon gamma plus gamma minus 1 upon gamma P lower gamma minus 1 upon gamma divided by P intermediate gamma minus 1 upon gamma plus 1. So this we will get, and this we will put equals to 0. So ultimately when we will arrange all things, so what we will get, P intermediate square is equals to P higher plus P lower. So what we'll get, P intermediate is equals to under root of P higher into P lower. Okay, this will be the end result. I'm not simplifying that you can do. Here I am writing also that after simplification. Okay, so this will be the condition for intermediate pressure for maximum work output. Okay, so the turbine work, what is the turbine work? Turbine work is the turbine work 1 plus turbine work 2. Okay, so first we will write turbine work 1. So what will be the what we have got, that Cp into T3 1 minus T4 upon T3. Okay, I have directly taken from here, which we have written here. Okay, so Cp T3 1 minus T3 upon T4 to the power gamma minus 1 upon gamma. Cp T3 1 minus P4 was wait, I wrote something wrong. Yeah, it is P4 actually. So Pi upon pH to the power gamma minus 1 upon gamma. Okay, so CPT3 1 minus P intermediate. We all know that from previous, P lower upon P higher upon pH gamma minus 1 upon gamma. CPT3 1 minus. So we will get under root P lower upon P higher to the power gamma minus 1 upon gamma. Okay, which we can further write here, Cp T3 1 minus P lower upon P higher to the power gamma minus 1 upon 2 gamma. I will write this 1 upon 2 into gamma minus 1 upon gamma. Is it okay? Similarly, if we will put we will put there, so what we will get, T5 1 minus, I am directly writing this result only, P higher upon P lower half gamma minus 1 upon gamma. This we will get for turbine work 2. So for perfect reheating we know that T3 is equals to T5. Therefore, turbine this is only the factor which is separating these turbine work and 2. So since for perfect heating this is same, so we what will get, turbine work 1 is equals to turbine work 2. Okay, so for perfect reheating, temperature T3 should be equals to T5, T4 should be T6, P intermediate should be P higher into P lower. Okay, and turbine work 1 should be turbine work equals to 2. This is very important. Okay, hello, hello,
Yes, sir.
is there any problem till this? Hello,
No, sir.
okay. This is for preheating for maximum work output. Okay, similarly, the third case which is by which we can increase the efficiency of the gas turbine cycle is by intercooling. Okay, so intercooling is almost same to reheating. The only difference is that in intercooling, we are increasing the efficiency of the cycle by decreasing the compressor work. So we are increasing the network. Network is turbine work minus compressor work. So here we are decreasing the compressor work. So by this network output will increase. Okay. So the cycle will look like this. This is 1, 2, 3, 4, 5, 6. Okay. So this will be P lower is equals to P1 equals to P6. This is P higher is equals to P4 is equals to P5, and this is P intermediate is equals to P2 is equals to P3. So can you tell what will be the effect of this intercooling on the performance of the that gas turbine? What will be the effect on the turbine work?
Reduce.
How it will reduce?
Sorry, increase.
Turbine work will there will be no effect on the turbine work. Na? It was it is same. Here we are not. Here we are only decreasing. Turbine work is same. Here we are only decreasing the compressor work, as I mentioned here. We are increasing the net work output but decreasing the compressor work. So turbine work no effect. It will remain constant. Okay. Here and compressor work is decreasing. Network output will increase. Okay. What will be the effect on the heat addition? Can anyone tell? Hello.
Lesser.
No, it will increase.
Increase.
Wait, I'll
Sir,
show.
4 to 5 is same.
Yeah, I'll show you how it increase. Previously, if we will see the cycle. So if we are taking simple Brayton cycle. Okay. So previously this was 2. Okay. So what was the heat? H5 minus H2. So now QH dash, what will be this? H5 minus H4. Okay. So this since temperature 4 is lower than T2, T2 is higher. Therefore, heat addition will increase na this much.
Okay, sir.
Okay. What will be the effect on the heat rejection?
Increase.
Yeah. Yeah, it will increase because previously it was what was that? Previously it was H2 minus H1. Now it is Qi dash will what will happen? H2 minus H1 plus H4 minus H3. No, wait. I have written wrong.
Sir, H6 minus
Yeah,
H1.
I have written. Previously it was S6 S6 minus H1, and now it is S6 minus H1 plus
2
H2
minus.
minus S3. So it will also increase. Okay. Now I will not derive that since it is all this cycle is almost similar to that reheating. So what will be the condition? Condition for maximum.
Sir, how compressor will decrease?
Yeah,
Sir, how compressor will decrease? That is, it is two process.
yeah. Here, see, previously we will compressing the gas from 1 to 2. Okay, so here, since we are decreasing the temperature again here from 2 to 3, so what will happen? The compressor work previously the T2 was higher, so T4 is lower than this 2. That's why this heat rejection is reducing. We are decreasing the temperature of the gases which are entering into the combustion chamber. That's why the compressor work is decreasing. We are not directly that in one compressor we are not increasing that much temperature. We are first heating and then again intercooling that gases coming out of the compressor work and then supplying them. Hello.
But it is two times compressing.
Yeah, it is compressing, but wait, I'll show you. This I will show you on the PV diagram. Okay, this is pressure volume. Okay, so initially what it is happening. This is lower pressure. Okay, this is higher pressure, and this is some intermediate pressure. Okay, so first we are what in the process 1 to 2 in previous. Suppose we'll assume this point as 2 dash. Okay, so what we are heating in one compressing the whole in one to 2 dash in the ideal Brayton cycle. Okay, so now by intercooling what we are doing, first we are compressing the air to 2 dash 2. Okay, and after that what we are doing here, we are at constant pressure. At constant pressure 2 to 3 has the same pressure, so at constant pressure what we are doing, we are rejecting the heat. So this will become 3. After that again we are compressing it. Okay, so it is 4. So this much amount of that work we are saving. Have you got now? Saving
Yes, sir.
of work due to intercooling. Have you got now clarity how that compressor work is reducing?
Yes, sir.
Previously the compressor work was this much whole area, 1 2 p higher p lower. Now it is p lower 1 2 3 4 p higher. So this much work we are saving due to intercooling, because of which the network output is increasing. Okay,
Okay, sir.
Okay.
now I'll not derive the that part because it is almost similar to reheating. So you tell me condition for maximum work output with perfect intercooling. Okay, so what will be the conditions for the maximum work output with perfect intercooling? This we have discussed in this reheating. So what will here, what will be the condition? You tell. I will not tell this.
Same as geometric mean of those pressure
Yeah, intermediate pressure will be,
will be geometric mean.
yeah, or other conditions like temperature and compressor work. This is the first condition. Second condition should be for perfect wait, can you see here? So for perfect this temperature T1 should be equal to T3, T4 should be T2, T1 should be T3, and compression work 1 is equals to compression work 2. T1 should be equals to T3. Okay, T2 should be T4, and 4 should be compressor work 1 should be equal to compressor work 2. Okay, the derivation would be almost same like that we have done for reheating. Only that case was for that we are reheating in the turbine. So here we are cooling in that compressor. Okay. Hello.
Yes, sir.
So I'll not derive that. We'll directly do the question. Okay. So we'll do one question that was asked. One big question. It will be covering all the three topics. Basically, both the topics, reheating and intercooling, because both are same. Okay. So this question was basically asked in IEES exam. I have taken this question because it is covering both the topics in same problem. Okay. So in the question they have mentioned that there is a regenerative reheat cycle. Okay. In this, air is entering at 1 bar pressure and 300 Kelvin temperature. Okay. Into a compressor. ठीक है, which is having intercooling between two stages. Okay, this they have mentioned. So what second what they have mentioned in there, air is cooled up to 290 Kelvin and 4 bar pressure wait here air is leaving first stage compressor is from here it is cooled and up to 290 Kelvin and 4 bar pressure. Okay, in the intercooler and subsequently compressed to 8 bar pressure. Okay, after that compressed air leaving second compressor passes through regenerator having effectiveness of the regenerator is equals to 0.8. Okay, after that the that uh, after the regenerator that air passes through combustion chamber. Okay, due to which its temperature increases to 1300 Kelvin at inlet of turbine having expansion up to 4 bar, and then reheated up to 1300 Kelvin before again expanded to 1 bar pressure. Okay, these exhaust gases from turbine passes through regenerator. Okay, so what we have to find? Efficiency of the cycle. This we have to find in the question. So basically I will draw the problem for you, that is temperature entropy curve. Okay, so the what they have mentioned, this is 1 2 3 4, that is temperature TA. Okay, this is 5 6 7 8. Okay, so they have what they have mentioned, this is regenerator. They have mentioned the gases from here will go here in the regenerator and will reheat. Okay, so the temperature also will decrease here, it will become PV here. Okay, so this will be regenerator whose effectiveness is 0.8 they have mentioned. Okay, so what they have given, that temperature of the inlet air is 300. Here they have mentioned 300. T1 is 300. T2 we have they have not mentioned. T3 they have again mentioned. What they have mentioned, that 1 bar into and 2 stages. First stage of the compressor, air leaving first stage of compressor is cooled up to 290. So what they have mentioned here, T3 they have mentioned 290 Kelvin. Okay, and pressure P1, P lower, P1 is equals to P8 is equals to 1 bar they have mentioned. Intermediate pressure for both the cycle they have mentioned 4 bar. Okay, this is also P intermediate, this is also P intermediate, so they mentioned 4 bar for it. And P higher, that is P4 P5, they have mentioned what they have mentioned, this temperature. Hello, have
Yes, sir.
they mentioned no, they haven't mentioned that, but I think there is no requirement for that. Again, what is the that we can calculate, I think so. So that temperature T5 they have mentioned in the question, what they have mentioned, 1300 Kelvin. Okay, and again what thing they have mentioned, there is a perfect reheating, so T5 equals to T7 they have mentioned here. Air passes through the combustion chamber having 4 bar and then again reheated to before again expanding to 1 bar. Okay, so T7 or T5 both are 1300 Kelvin. So what they are these are the information which are given in the question, and finally they have asked us to calculate the efficiency
And
of the
pressure.
cycle. Pressure, they have
8
mentioned,
bar.
yeah, 8 bar, I think. Here it is 8 bar. So can you calculate the efficiency? So first, can you tell what will be the efficiency of the cycle? Efficiency, what it is? Net work output
W
upon
net
heat addition.
Q.
Okay. So what is the net work? Net work is turbine work minus compressor work upon heat addition. Okay. So what is the turbine work? Turbine work from the question, tell me from the diagram. Hello.
H5 minus S6
Hmm.
H7 minus H8
plus
minus H2 bracket में H2 minus H1 minus H3 H4 minus H3.
Okay. I am only first I am only writing the turbine work. What it is? H5 minus S6 plus S7 minus H8. Okay. And compressor work, what it is? H2 minus H1 plus H4
H4 minus
minus H3. And heat addition, what will be the heat addition?
H5 minus H4
H5 minus H4. No.
HA
H5 minus T. That A.
Yeah. Add. What will be the added?
H7 minus H6 plus.
Yeah. Plus H2 minus H3.
So that is heat rejected, no, sir?
Yeah, heat rejected, but that also we have to mention in the problem in that part, because it is a decreasing, but that also we have to write. That is also some type of heat rejected. No, wait.
we are considering only sir heat input.
Yeah. Right. So what will be the H5 minus HA plus S7 minus S6. Okay. So can you calculate all here in the problem they have CP will be the same, so we can directly write efficiency is equals to CP will be same, so I will directly cancel out those and we will write that like that, T7 minus T8, okay, minus that will be turbine work, T2 minus T1 plus T3 and T4 minus T3 upon T5 minus TA plus T7 minus T6. So in the problem they have mentioned T5, they have mentioned T7, they have mentioned 1300 Kelvin. Okay. They have mentioned T1 is equals to 300 Kelvin. Okay. They have mentioned T3 290 Kelvin. Okay. So rest values you can calculate from here by because in the question it is an isentropic process. By isentropic compression and expansion identities, you can calculate the other temperature, that is T6, T7, T8, T2, T4. Can you calculate all those and tell me what you have got? What you have got? T2. T2 is missing here, and what other T4 it is missing. T6 we have to calculate.
Sir, can you tell what are the pH and PL?
PI it is 1 bar. No, P lower. PI it is 4 bar and P higher it is 8 bar.
सर पीआई इज फॉर हीटिंग और कूलिंग पर्पस, मतलब किससे एसोसिएटेड है ये वाला पीआई?
पीआई इंटरमीडिएट प्रेशर है, ये जो है ना,
मतलब कौन सा वाला?
ये
7 to 6 और 3 to 4?
या या ये वाला जो है ना, इसको देखो डैश डैश करके सेम है ये वाला, इधर से समझे, ये पीआई है, 4 बार
पर
प्रेशर।
सर ये तो जो हमने मैक्सिमम परफेक्ट के लिए निकाला है वो तो आ नहीं रहा है 4 बार वैसे।
क्वेश्चन में मेंशन है, ये हमने निकाला नहीं है एक्चुअली,
ओके सर, ओके सर।
ये क्वेश्चन में गिवन था। After calculating all these values, please put all these values in this equation. So you will get the efficiency, and tell me the efficiency also what you have got. First tell me the temperatures. What you have got, T2, T4, T6. Has anyone got what is T2?
445.79 Kelvin.
Okay. So you can have 445.7 Kelvin. Okay. What is T4? Also, one more temperature we have to calculate. What it is? TA. TA also we have to calculate. Okay. For that, TA effectiveness of the regenerator is given. You can use that formula. Pointed.
सर T4 is 353.5.
Yeah, it is correct. 353. And T6. Just use the that if I'll show you T2 by for asymptotic process we already know that T2 upon
1066 T3.
yeah
Sir, T6.
yeah T6
Six.
10666. Okay, it is correct. So it will be that pressure gamma for pressure take 1.4 upon 1.4. So from here T2 you will get 445.7 Kelvin T2. Again we will use the same T4 upon 290 Kelvin for second compressor. So pressure here will change 1.4 minus 1 upon 1.4. So from here we will get T4. What we will get? 353 Kelvin. Okay. Now for the third process, 1300 Kelvin upon T6 is equals to 8 upon 4. 1.4 minus 1 upon 1.4. From here we can get 1066 Kelvin. Similarly,
And T8 is 874.8.
yeah, upon T8 is equals to 4 upon 1, 1.4 upon 1 upon 1.4. So from here we can get T8 is equal to 874 Kelvin. Okay. Now only temperature remaining is TA. So how we can calculate? We know that effectiveness of the regenerator. It is
0.8.
yeah for T4. I am directly writing the formula. You already
TB.
know that what is the effectiveness of the heat generator. Okay, so the what we have what was the definition that the what is the heat which we have transferred. Can you tell me the definition, anyone? What we have, it was the actual temperature rise in
Upon actual temperature.
upon maximum temperature rise. Okay, so the actual temperature rise, what it is? Ta minus uh, Ta minus T4 na. Yeah, actual temperature rise is Ta minus T4, and the maximum possible what is we can get T8 minus T4. It is the exhaust of the turbine. It is 8 point, and if we will minus T8 from T4, so maximum temperature rise what we can get T8 minus T4, and actual temperature rise what we are getting Ta minus T4. So this will be the effectiveness. That's what I have mentioned here. So it is a 0.8 it is given. Okay, so Ta we have to calculate. T3 we have got 353 Kelvin, and it is 874 minus 353. So Ta what we will get here 770 Kelvin. Put all the above values in that this equation efficiency and give me the answer. What will be the efficiency? Has anyone got the answer?
What was the value of T2?
Yeah,
What was the value of T2? 445.
yeah, 445.7. You only calculated na?
Yes, sir. Yes.
What is the value of T5? 1500 minus we have got 770 Kelvin plus T7 T7 200.
Mr. Efficiency 48.9%.
59.07%.
Yeah, 59. Whosoever has got it is correct. Minus what is the other T6 066. So efficiency will roughly comes around 59%. It is the correct answer. So I will do one more problem on this, which came in GATE 2020. Okay, and then this topic will be over. From the next class, we will start with the that is steam cycle, Rankine cycle. So I'll give you that question also, which was asked in GATE 202 2028 came. So what they have given that the should I directly write on in that diagram na? You'll be able to they have given an intercooled Brayton cycle. The compressor overall compression ratio they have given is straight actually 1 2 3 4 5 6. So overall compression ratio they have given that what will be the overall compression ratio? It will be they have given P3 upon P1. Okay, that is P1, that is P2, that is P3. Okay, that will be, we can write P lower, P intermediate, that is P higher. Okay, so they have given that overall pressure ratio, or you can write P higher upon P lower they have given, and that they have given in the question is 6. Okay, So air is compressed in a two-stage compressor, and its overall pressure ratio is given this. Okay, the inlet condition they have mentioned, that is air will enter at point 1, that is P1. They have given 100 Kelvin pressure. Okay, kilopascal, and temperature is they have mentioned 300 Kelvin. So they have asked to calculate the intermediate pressure. So can you calculate what will be the intermediate pressure, or P2 or P3, anything? P2 is equals to P3 is equals to P intermediate. They have asked to calculate this in the exam. Pressure one you already know, and overall pressure ratio they have given. Overall pressure ratio P3 upon P1 they have mentioned 6. P3 we will get from here. P1 they have given 100 kilopascal, so P3 will become 600 kilopascal. Okay, now what it P intermediate is under root of P1 into P3, so 100 into 600, what we will get?
245.
240. Yeah, we will get roughly exactly not around 245 kilopascal. So this was the answer. They have actually given some range in the exam. Actually, I don't remember the range right now. I only remember this only. So it was roughly around this only. So they will generally give a range. So they might have given 244 kilopascal to 245 kilopascal. In between this, any answer would be acceptable. Wait, I'll write the range here. 246 or also you can write. They will always give a range. So if your answer will lie in that range, you will get the full marks. Is it
Sir,
clear?
instead of P3, there should be P4.
Yeah, sorry. It is P4. Sorry. P4 upon P1 they have given. Yeah. Actually,
Sir, is there in traveling we can access this PPT, sir?
PPT, you also want the PPT.
हाँ
Okay.
सर, रिकॉर्डिंग का तो है पर पीपीटी का नहीं है.
ठीक है, PPT मैं शेयर कर दूंगा. PPT. Can you share? Can any one of you can make a WhatsApp group so that I can share all those this PPT and all in that WhatsApp group?
Yes, sir, we have.
You have already have the WhatsApp group, na?
Yes, sir.
Can you add me in that group? My number. Wait, I'll give you my number. WhatsApp number. I'll share. I will share all those there only.
Okay, sir.
Today there is no other class.
सर है
The
7
class.
बजे सर.
Okay. Please add me in that WhatsApp group. Then I will share.
Sir, you can join that group.
Okay. Wait. So we'll end the class today here only, and from the next class we will start from the Rankine cycle.
Sir, next class, I mean, from next week onwards, only on Wednesday.
Yeah, from next week the classes will only be from the Wednesday,
Okay, sir.
because
Sir,
actually I joined late. That's why. Yeah.
Sir, recordings available, sir.
Recording you can recording I have shared my channel actually. Wait, again I'll share my channel.
So please share the YouTube link, sir, so that
Yeah,
we can ask.
yeah, I'll share my channel there. Wait.
Okay, sir. Thank you.
Sir, P intermediate is equal to square root of P high and P low.
Yeah,
This condition is only for perfect reading
yeah,
or
because
intercooling.
in the question they haven't mentioned anything about the sorry, I forgot to mention. They have mentioned actually. They have given that in the ideal reheating, ideal intercooling. They have mentioned.
Okay, means it can vary. Means
Yeah,
sometimes we can't use this condition.
if they haven't if they will mention that ideal either intercooling, then it is that perfect intercooling only. If they will not mention either intercooling, then they will give the temperature T3, like the in the previous question they have mentioned that T3. Here they have mentioned that it is 290 Kelvin. In the here in the
Means
previous problem they mentioned na, that temperature T3 it is 290 Kelvin. So if they will not mention the idle intercooling, then they have to mention the temperature T3.
okay, means other than ideal case, we cannot use this formula. Pi is equal to square root of.
No, no, but I don't think so. In the gate, they will give that much difficult problem. I have only given this question so that it is a bit tough type of question. If you will not understand all these concept like reheating, intercooling, then you cannot solve this problem easily. So that's why I have given that this question tough type of question. In gate they normally ask simple type of question only like this. They won't give such type of questions like that will consume more time actually. For the gate exam, they generally try to give the question in such a manner that the student can easily solve in 1 to 2 minutes.
Okay, sir.
So I don't think so they will give if they will give problem, they'll give like that only simple, because they have to solve, you have to solve 65 questions in 3 hours. So they will give that type of they'll concept type of questions they ask like that like the one we have mentioned in the class, what is perfect reheating, perfect intercooling, all those if you will remember, then you can easily answer.
Okay, sir. Thank you, sir.
Okay, wait, I'll show you. uh, actually I have shared that power plant engineering gate PPT. Have you got that in the group? Can you check? Hello.